All right, so for this first piece, function operations, page 24. What we are doing, guys, is remember operations are adding, subtracting, multiplying, or dividing. So there's just 4 things that you can do here. Add, subtract, multiply, or divide. And remember what these are. This is f of x. I am going to highlight f of x in orange, just so you can see how I substituted in. I'm going to highlight g of x in green. And then we're going to do some order of operations. But before I start, y'all, how many terms are in f of x? 2. Good job. And how many are in g of x? 3. All right. Good. I'm really glad to hear y'all know that. All right. So for number 1, what do we do with number 1? Well, we're going to be doubling g of x. I know we're doubling g of x because there's a 2 in front of it. Then we're going to be subtracting f of x. So what I'm going to do is I'm going to go ahead and write the 2 that's already there. And it's 2 times g of x. And remember, g of x had 3 terms. And then we're going to end up subtracting f of x. And remember, f of x had 2 terms, and f of x was 3x minus 2. Now remember, we're subtracting all of f of x, y'all. I have to go back and put this in brackets, because when you distribute that negative, you have to distribute it to both of those. Okay, speaking of distributing, let's go ahead and distribute the 2. How many times are we distributing the 2? Yeah, 3 terms, 3 times. Good job. So this is going to be 2 times x squared minus 12x plus 10 minus 3x plus 2. And then from there, we're going to combine like terms. Y'all, there's nothing to combine with 2x squared, so that's going to be first again.
Wouldn't it be 3x minus 2?
I distributed the negative. Remember, when you distribute the negative, the signs just change. Okay. But, y'all, we have a couple of x terms that we can combine. So that negative 12 and that negative 3 is just going to be minus 15x. And then, do y'all know what the last piece is going to be? Yeah, plus 12. Good job. And then I'm just going to box in my final answer here. By the way, if you have 2 different color highlighters, you're going to need those later. It's going to make life a little easier for you. All right. So number 2, for number 2, all we're doing is taking g of x and subtracting 4 from it. So remember, g of x is x squared minus 6x plus 5. And remember, it's minus 4. And y'all, I use those brackets just so you can see where I plugged it in. But the brackets don't really mean anything. I'm just showing you where I substituted it in. So really, guys, all we have to do is do 5 minus 4 for number 2. So 5 minus 4 is going to give you x squared minus 6x plus 1. Just operations, just getting used to looking at functions and combining like terms and stuff like that. No. By the way, if there's not an equal sign in the problem, you can't solve it. So no solving at all. There's no equal sign there. All right, so that's just simplifying. Let's go ahead and take a look at the next part. And this is going to be it for the day. The next piece is called composition of functions. And composition is composing a brand new function based on what you have. So you're going to make something brand new. And what we're going to do is we're going to put one function into the other. If you guys look at number 3, it looks like the word fog. It's not fog. It has a symbol. It means f of g, which means that g is going to get dropped into f, and I'll show you what I mean. Whatever is printed last gets dumped into the first. So G is going to be put in for F. F over here on number 4 is going to be put in for G. Same thing down here. 5 and 6 are still compositions. If you look at number 5, which letter comes second? The G. G is going to get dumped into F. Over here, F is going to get dumped into G. Let me show you what I'm talking about. All right, so back here on number 3, we're still dealing with f of x and g of x, but they changed. This time, f of x is just a 3x, and g of x is x squared plus 2. So, what this means when I say I'm going to put g into f, every time I see the letter x on f, I'm substituting that in for it. So every time I see the letter x, that's the substitution. So x is going to equal x squared plus 2. So when I begin writing f of x, there's a 3 there, but look what's next. Just the letter x. Every time I see the letter x, the other one gets written for it. So I'm going to open parentheses, and I'm going to put in g of x. That's this first piece, that weird thing that looks like fog. It's not fog. It's that right there. We put in g for the x value in the other equation. And then all we can do here, y'all, is just distribute. So let's distribute. So this is going to be 3x squared plus 6. And remember, that's f of g. And that would be all that I would have if I didn't have this negative 2. That negative 2 lets me know there's another step involved. So now that we have this brand new composition function, this is brand new. It has not been written anywhere on the page. Now I drop in an input. The input's negative 2. So every time I see the letter x, I'm just going to put in a negative 2. So this is going to be 3 times negative 2 squared plus 6. And y'all, for the love of math, do not do 3 times negative 2 first. Look at your order of operations here. We're going to get a single number, but think about order of operations. What would you do first? The exponent. Y'all, what's negative 2 times negative 2? Yeah. All right, so y'all, that's just a 4. What's 4 times 3? And then add 6 to that. That's the answer. Just 18. So let's write 18. And then I almost ran out of room, but I can squeeze it in. I'm going to show you what the final answer looks like in this composition form. It is going to be f of g, and then I'm going to rewrite the input of a negative 2. And then what does that equal? What is the output we got? 18. I'm just going to write an 18 right there. So again, I'm just dropping one into the other. That's it. Let's look at number 4. Number 4 is almost the same as number 3. We're just reversing the order. So this time, F is going to get dropped into G. So wherever I see the letter X into G, I'm writing what F of X is. What is F of X? A 3X. So it's a substitution game. That's all it is. Okay. So g of x, I've been using green ink for g of x, so I'm just going to kind of keep it organized here. So the first thing I see for g of x is an x. And that x is going to be squared. And then remember there's a plus 2. And remember where we see the letter x, we're dumping this in. So I'm going to write a 3x here in parentheses. And then we're gonna multiply this out. Do y'all know what 3x times 3x is? What's 3 times 3?
9.
9, and then x times x is x squared. So this, our brand new composition function, is going to be 9x squared plus 2. That is g of x. That's the composite function. I got one more step. I have an input of a -2. Just going to drop in a -2 where x is. And then don't do 9 times -2. That's still a 4. -2 times -2 is 4. Y'all know 4 times 9? Yeah, then add 2. So that's it. The answer is 38. So we're going to do it one more time, and then we're going to quit and move on to something else. So this time, if you notice, you have a lot of parentheses. It still means the same thing, guys. We're going to put G in for the letter F, and then we're going to have an output of 5, or an input of 5. That's it. Okay, it looks like it changed, though. This time, f of x is x plus 2. G of x is x minus 2. G is written second, so that means anytime I see the letter x, I'm going to plug in x minus 2. All right, here we go with f of x. F of x starts out with x. So we are going to write x minus 2. That's where I dropped in g of x. But don't forget there's a plus 2 right there. So I have to have a plus 2 out here. And again, y'all, I just drew those brackets so you can see where I plugged in g of x. Those brackets don't mean anything. That's the same as this. What does that simplify to? Just to x. So watch how I write this. I'm not doing the input value of 5 yet. F of g of the placeholder of an input x equals x. Now let's plug in our input. So I'm going to rewrite this weird looking notation again. F of g. Now I'm going to rewrite it how the problem is. I'm going to put -5 in there. I'm sorry, +5. So remember that 5 is an input. Your x's are inputs. So I'm going to drop a 5 in here for the letter x. So the answer is 5. When you have just the x, the input and the output are exactly the same. When you have just the x, the input and the output are exactly the same. All right, let's reverse the order. This time, we're going to put f into g. So every time I see the letter x for g, the green one, every time I see an x, I'm going to dump in x plus 2. So here I go. We are going to actually start out with a letter x. So f of x comes first. But remember, your g of x had a -2 behind it. Turns out to be the same exact thing, y'all. So I'm going to write g. I'm so sorry. Yeah, I am. I'm going to write g of f of x. Remember, all of that simplifies to just an x, which means whatever I put for the input, the output's going to be the same exact thing. So that's like my generic form. I'm going to go ahead and plug in the input, which is letter A. So now I'm going to recopy what is printed right next to number 6. When I drop in A for x, the answer is just A.